Today we want to look at reference angles because we want to apply trig functions to angles that are bigger than 90 degrees. We want to apply trig functions really to any angle, not just acute angles in a right triangle. So for that, we're going to need to see what these bigger angles mean and how we can apply a right triangle to even these other bigger angles. So to start with, I want you to find these four values: the sine of 60 degrees, sine of 120 degrees, sine of 240 degrees, and sine of 300 degrees. Here's the first one. Sine of 60 is 0.8660. What do we get for the sine of 120? Same thing. 0.8660. What do we get for the sine of 240? Negative 0.8660. And what do we get for the sine of 300? Same thing. So before we talk about this in more detail, what is the exact value of the sine of 60? Think about these special triangles that showed up in the homework that I didn't talk about in class. What is the exact, does anybody know the exact value of the sine of 60 degrees? What is the exact value of the 0.8660? How do you remember? I do, but I'm pretending that I don't. Someone does. I have to look down. Square root of 3 over 2. Awesome. It is square root of 3 divided by 2. Specifically, square root of 3 divided by 2. The quotient of the square root of 3 and a regular old 2 in the denominator. So awesome. Thank you. So the exact value is root 3 over 2. If we build a 60-degree angle, that means we could say that the opposite is going to be the square root of 3, and the hypotenuse will be 2. So this is telling us some stuff about a right triangle. So if I build a right triangle with a 60-degree angle, I could set the opposite up as root 3 and the hypotenuse as 2. Thinking of this special triangle, if there's a 60-degree angle in a right triangle, what's the other angle? 30. Because the angles in a right triangle, the acute angles in a right triangle are complementary. And what is the side opposite 30? If we remember all of our values. Or if we remember Pythagorean theorem. How much is opposite 30? So it's 1, 2, and a square root of 3. Here's what we're going to do with these four angles. I'm going to draw these four angles in standard position on this circle up here. Standard position means the initial side will be on the positive x-axis, and then the terminal side will be in one of the four quadrants. And then we'll just wind around to the terminal side. We have two directions of rotation. I can go counterclockwise or I can go clockwise. We're going to say that counterclockwise is positive. We just decided this a long time ago. Like I was there. So I'm going to put a 60-degree angle. So I'm going to say standard position has the initial side on the positive x-axis Standard position means the initial side is on the positive x-axis. That means start here. That means here is where we will be at 0 degrees. And counterclockwise is positive. So an angle that measures positive 60 degrees will be here in the first quadrant. Let me see what I did. I'm just making go out to the end of the circle. So here's with 0 degrees, and then here's going to be 60 degrees. If we go all the way up to the positive y-axis, what angle is that? Where are we at? 90 degrees. So that'll be in the first quadrant is the 0 up to 90 degrees. So if vertical is 90 degrees and we've got this 60-degree angle, how much is in this little gap right here? What's in this gap? How much? 30. So it's 90 degrees up to there, and I want to draw a 120-degree angle. So how much further do I have to go to get to 120 degrees? I've got 60, then 30 to get to the vertical. How much further past the vertical do we have to go to get to 120? What's left over to get there? Another 30. So it's going to be another 30. Another 30-degree angle here. So that's 60, the 30, and the 30. That'll make a 120-degree angle. Everybody see it? So if here's 0 at the positive x-axis, 90 at the positive y-axis, where are we at the negative x-axis? How big is that angle going all the way over? That'll be 180. If we go this direction, it'll be positive 180. If we go clockwise, it'll be negative 180, but that ends up being at the same place. So if this is 180 degrees at the negative x-axis, how much is it from this 120-degree angle down to the positive x-axis? 60. Any questions? Realize I made that 60 too big. So here's a 60. Here's 120 degrees. So if there at the negative x-axis is 180 degrees, how much further do we have to go to get to 240 degrees. So over here is going to, somewhere between here is going to be a 240 degree angle. How much is it from the negative x-axis to that 240 degree angle? 60 degrees. Now, if we keep sweeping down to the negative y-axis, how big is the angle going 3/4 of the way around? What's 3/4 of 360? What's this place going to be? 270. How far is it from that 240 to the 270? How far do we have to go to get there? What's this little piece in here? 30. Now, if that angle down there is at 270, that negative y-axis, how far do we have to go to get this other one that I picked, 300 degrees? How much further from 270 to get to 300? Another 30. Then if we got that 300 degree angle, we want to go finish off the circle. How far from that 300 degree angle up to the full circle? Another 60. This is the thing that all four of these values have in common. So this 300 plus this 60 degree angle means that 0 degrees is the same location as 360 degrees. These four angles, 60, 120, 240, and 300, all have what we call a all have what we call a 60 degree reference angle. Notice that the reference angle goes from the terminal side of the angle to the nearest part of the x-axis. So this is the angle between the terminal side and the nearest x-axis, positive x-axis or negative x-axis. I need to go backwards. Positive x-axis or negative x-axis. So this is the angle from the terminal side to the nearest parts of the x-axis. This is how we're going to describe a reference angle. We go from the terminal side to the nearest part of the x-axis. From the terminal side to the nearest part of the x-axis. From the terminal side to the nearest part of the x-axis. From the terminal side to the nearest part of the x-axis. This 240's got to go back, because the nearest part of the x-axis is the negative x-axis. The 300 will keep going because the nearest part of the x-axis is the positive x-axis. Any questions? That's what we mean when we talk about a reference angle. Yes. Yeah, the terminal side is just, so all these red lines are the terminal side of the four angles. So this red line here, this is the terminal side of the 60 degrees. This red line down here, we go all the way around, and this red line here is the terminal side of the 300-degree angle. No. In standard position, our initial side is always the positive x-axis, so we measure from there. So even if we went negative and called this 300-degree angle negative 60, this is still the terminal side. The initial side is always the positive x-axis, so the terminal side is just where the angle ends. So that's the terminal side of the 300 degrees. But the initial side is always the same place, the positive x-axis. That's whether we're measuring a positive or negative angle. How's everybody, okay? What does it look like is the case when we have a trig function? Now we're going to generalize a lot, like immediately. But we have a trig function of a bunch of angles with the same reference angle. I took the sine of these four angles and they all have the same reference angle. What's the only difference in the values? It's always 0.8660, 8660, 8660, 8660, always root 3 over 2. What's the only difference? Well, the quadrant that it ends in, yes, but just looking at these values, it's got root 3 over 2, another root 3 over 2. This one's different. It's negative. It's negative root 3 over 2 for 240, and it's negative 0.8660 for 300. So if you have angles with the same reference angle, the value of the trig function, the absolute value of the trig function will be the same. At least that's what this data suggests. And since I'm the instructor and I just said it, you're all just going to believe it. Proof by authority. Because I said so. We might not see why that is yet. But this is one of this is a hypothesis that we can form. It looks like we have sine of 60, 120, 240, and 300. Those angles all have a 60-degree reference angle, and we always had the same absolute value, root 3 over 2. Let's grab the cosine of those four angles. So right now, we're thinking, when we do a trig function of angles with same reference angle, absolute value is the same. This is one of those terrible things of the English language crashing into math. Sine is the trig function, S-I-N-E, sine, S-I-N-E is the trig function, S-I-G-N is a sign, positive or negative. Ugh. I'd be like, oh, they only differ in sign. It's like, oh, but the sign is the same for some of them. It's like, oh, no, they only differ in sign, positive or negative. So we could say that they only differ in parity. It's like one of those D&D things with like levels. First level character has access to first level spells. Seems to make sense, right? But you don't get access to second level spells until you're a third level character. So we keep using the word level. Dang it. So we have these four angles. They all have the same reference angle. And the only difference in the values is positive or negative. Let's grab another trig function and see if that is the case. Let's take the cosine of these four angles. So let's try the cosine of 60, half. Cosine of 120, negative a half. Cosine of 240, negative a half. Cosine of 300, a half. That would be evidence in favor of our hypothesis. I have four angles with the same reference angle in different quadrants. The only difference was the parity, positive or negative. Oh wait, parity is even odd, isn't it? Oops. So the only difference in the cosine of these four values, we have the same absolute value, 1/2, sometimes positive, sometimes negative. Any questions? Let's test tangent. Let's see what tangent does. The tangent of 60 is 1.732. The tangent of 120, negative 1.732. Maybe it's going to be like cosine. Tangent of 240, well, back to positive, positive 1.732. And the tangent of 300, back to negative. 60, 120, 240, and 360 all have the same reference angle, 60 degrees. So when we apply a trig function to each of those four angles, we get the same absolute value. They only differ in sign. Any questions? How's everybody okay? So here we tested our hypothesis. With cosine and tangents. Step one. We wanted to define what a reference angle is, and we wanted to notice something about reference angles that's going to be relevant to our. Any questions? Comment? Snide remark? Deep thoughts? Astounding observations? How's everybody okay? You're all giving me the afternoon class look. It looks like this. This is very different than the 8 o'clock class look, which looks like this. I know you don't think they're the same, but I've been in this business for 20 years and I can tell. Mostly because there's a clock in that clock, and I can see it's in the afternoon. So I don't think I'm running a class at 2 o'clock in the morning. That'd be crazy. I'll go real quick. Funny, when I list times on things like the syllabus, like I list this class not as going from 1 o'clock to 3 o'clock. I say it goes from 1300 to 1500. As if people are going to think I'm running a class at 1 o'clock in the morning. That would be the most hardcore class. What time is class? 1 o'clock. Oh, after lunch. No. Middle of the night. What is this? Vampire University? All right, let's take a break. Come back and talk about some other reference angles. Maybe try to figure out if we can predict when the value is going to be positive and negative. All right, let's pause, take 5, come back and talk more about reference angles.